Hey guys, welcome. Let's talk about experiment 5. So we're going to be looking at experiment 5 today. I'm going to go ahead and share my screen so that we can take a look and see what's going on with that. I am currently in the ALEKS shell and I am viewing as a student. So I have got virtual lab 5 here, density of a cube, and let's go ahead and get started with this. So a couple of things about experiment 5. Key concepts. The International System of Units, SI, from the French Système International de Units, is used in scientific research to ensure consistency of collected data. Mass is a measure of the quantity of matter in an object and one of the 7 SI base units. Volume is the amount of space occupied by matter. Density is the mass of a substance divided by its volume. And a cubic centimeter equals 1 milliliter. Okay, so that is a thing that we need to know and is available to us. Okay. Sorry, trying to get my blood sugar taken care of. In addition to that, we will be looking at tearing and accurately using balanced, using calipers, measure the volume of liquids and objects, how to use a graduated cylinder to measure volumes of liquids and solid objects, and measuring the behavior of both objects and liquids with different densities. Before we begin, we need to talk about accurate volume measurements, and some of you I noticed had some issues with this, making your measurement of the meniscus. Okay, it is a little difficult in the labs that we do here because we've got to make sure that we're measuring that meniscus. So it is that curved portion, not the solid portion at the top that's flat. Okay, so we've got to make sure that we're doing that. We need to make sure that when we're looking at measurements of liquids, and we've got all of the air out of it, so we need to make sure that we're talking about something with no air in it. Okay, and we need some. We need to know the densities of some of these liquids when we're talking about them. So I'm going to go ahead and take a screenshot of this because we may need to know some of these liquid densities at some point. So I'm going to collect this because I may need it later. So collect that, put that into my notebook over here to 110 and put this in. So I will probably eat that at some point. Okay. So let's go ahead and go into the simulation. It says if the balance was not tiered to display 0.0 prior to adding the cube, which of the following statements are true? Select all and apply. Mass of the cube can be calculated. Mass displayed on the balance before the cube was added will need to be subtracted from the mass displayed on the balance with the cube. That works. No calculation is needed to determine the mass of the cube. That's not true. Cube can be reweighed after the balance has been tiered. That's true. Mass displayed by the balance is the mass of the cube. That's not true. So I'm going to go with that. Okay. So we're going to place the cube on the balance. I'm going to tear it first and place the cube on there. 0.95. And then I have taken care of that, so I can go to the next phase. It says use the caliper to pick up the cube. So I've done that, and I see that it is 0.999. 0.999. Cube volume is then 0.999 times itself. So you can take, and we don't do it once, so 0.999 times 0.999 times 0.999. Cubing that, and I get 0.99700. 3 sig figs, because that's what I have, so 0.997 is what I am with. And my cube density, 0.95 divided by 0.997, end up with 0.9528, should be 2 sig figs because my mass was 2 sig figs, so 0.95. That's what I end up with there. And recorded all of that, so I can go on. Yay! Now, use clean pipette to transfer 3 to 5 milliliters of liquid to clean graduated silk. And I'm going to do that for the methanol. So I'm going to pick up this and I'm going to go to the methanol. 2, 3. There, look, and I see that's exactly 4. Place the cube in the graduated cylinder. For your observation in the lab data. What I see is that it sinks. So in the methanol, it sinks. I'm going to zoom out, take chemical for disposal, but waste for disposal. I'm going to do the same thing with the diethylene glycol. 2, 4. Here, zoom in just to see 4 exactly. Pick one of these up, put it in here, and it's floating. So it floats. Put that in there, that in there. Cool. And now I'm going to go with water. 1, 2, 3, and 4. Rid of that. Make sure it's 4. It is. And put this in here. And notice that it floats as well. Okay. So I can close out of that. I can put this in here and put this in here. Okay. So that's all done. Polypropylene cubes have a density of 0.946 grams per milliliter. Identify the true statements. Cube sinks in methanol because methanol's density is less than the cube's density. Cube sinks in methanol because methanol's density is greater than the cube's density. Cube floats on water because water's density is greater than the cube's density. That's true. And the cube floats on ethylene glycol because the cube's density is greater than the diethylene glycol's density. Well, that's not true. So the diethylene glycol has a greater density than the cube. The cube sinks in methanol because methanol's density is less than the cube's density. So the cube has a greater density than the methanol does. Cube sinks because methanol's density is greater than the cube's density. Displacement, 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 displacement. I'm going to say methanol. So this is the only one that it's one of these two. Methanol's density greater than the cube's density. Oh, I knew it was one of those two. Use clean pipette to transfer 3 to 5 milliliters of methanol. 1, 2, 3, 4. Exactly. 4. 5. Use clean pipette to transfer methanol. 1, 2, 3. Sorry, we're supposed to do 2. Sorry. 1 milliliter of the diet glycol. There. Stir rod to stir it. There. Mm, 1.00. Cube in there, and it's 6. Okay.